Okay, this lesson is going to be all about dividing radicals. So the last one we talked about the multiplication rule. This time we're going to talk about the division rule. So it says if the nth root of a and the nth root of b are real numbers, then and b can't be 0. We can't get a 0 in the denominator because that would be undefined. Then the nth root of a divided by the nth root of b is equal to the nth root of a divided by b. So let's test one of these. So if that's the case, then the square root of 36 over the square root of 25 should equal the square root of 36 over 25. So just putting them together underneath one giant radical, putting that fraction under one radical. So if I look at the square root of 36, I get 6, and the square root of 25, I get 5. So this side simplifies to 6/5. And then I can do the same thing over here. 36 over 25 simplifies. Under the radical, that would be 6 squared, right? 6 times 6. And 5 times 5. And perfect squares under the square roots cancel. So I end up with 6/5. So it does in fact work. So it's totally okay to do that. Let's practice this skill a little bit. We look at question number 1. We have the square root of 243 over the square root of 27. Okay. And if you look at them the way they're written, the square root of 27 doesn't break down evenly. And so we would end up with radicals in the denominator, and that's a no-no. We know that from learning how to rationalize a denominator earlier in the year, and also with quadratic formula, and also from rationalizing the denominator when we learned trig and geometry. So by combining these two, we gain some advantage in being able to simplify it down further and get a final answer, where if we left them separate, we would only be able to simplify part of the problem. So we're going to do the square root of 243 divided by 27, or over 27. 243 divided by 27 is actually 9, and the square root of 9 is 3. So that actually works out very good for us. Now, let's try one with a variable in it. We have the square root of 12x to the 4th over 3x. So let's simplify what parts of that fraction we can. So 12 divided by 3 is 4. So I'm going to have the square root of 4. And then x to the 4th divided by x leaves me with x to the 3rd. And now I'm just going to break it down like it would normally. So 2 and 2. And this is going to be x squared times x. Right? So my radical now says 2 squared times x squared times x. This is the only thing that's going to be left under the radical. Perfect squares come out. So 2 times x square roots of x. Okay, 2x square roots of x. Nicely done. All right, the last one. So 4th root of 1024 x to the 15 over 4x. So 1024 divided by 4 is actually 256. And then x to the 15 divided by x is x to the 14. Okay, so let's break down the 256. So 2 and 128. 2 and 64. 2 and 32. 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So it's a 4th root, so I want groups of 4. So there's 1, and there's 2 groups of 4. So if I rewrite this, I'm going to have a 2 to the 4th, and another 2 to the 4th, and then I'm going to have groups of 4. So 4, 8, 12, so 4, 8, 12, 13, 14. So I'm going to have that x squared left over, okay? Everything else is a perfect 4th power under a fourth root. Cancel, 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 cancel. 2 times x times x times x times the fourth root of x squared, and then simplify. 2 times 2 is 4. X times x is x to the third. Fourth root of x squared. Even power comes out as odd. So put it in some absolute values and you're good to go.